Hello, this is Jesse Miles. This is my chapter 11 homework here. I believe we just have to make a video, kind of walk through some of the steps of the problem solving. So yeah, here it is. Here's the first problem, first and second, but in the first one, you have your position function, your velocity function obviously is the derivative, and then the acceleration is the derivative of velocity. So I got those three first, then set it equal to 0, factored it out, found out where the acceleration was 0, and that ended up being -1/2, which doesn't really apply with time, and then 2/3 seconds. So you plug in x to 2/3, v of 2/3, and that's what you end up getting. Sorry, I'm getting kind of over a cold right now, so apologize my sniffles and my voice. Next one we had x equals 0, initial velocity. I believe this was an object going into something, and it gets 4 inches into it, from what I remember. Got some of the basic equations. V equal v0 minus kx, and x is 1/3 of a foot. That was because 4 inches out of 12 inches, which is a foot obviously, is 1/3. So, and that was at v equals 0. Yeah. And so then you kind of plug all those in. 0 equal 900 minus k times 1/3. Do some simplifying here, and then move on to let's see, we did the derivative of velocity here, so that because we have the velocity function, so we took the derivative to get the acceleration function, and then you end up getting -2.43 times 10 to the 6th. At least that's what I got. Got to do some integrating. This one, I think, yeah, right here, we have dx dt equal v0 minus kx, and so you have to divide by v0 minus kx, obviously, to get, basically, I think it's implicit, not differentiation, but integration in this case. And yeah, so kind of fun stuff. Haven't had to do some of this stuff in a while, so it was definitely good to go back and redo some of it. A lot of it reminded me kind of how statics is as well. At least the problems looked kind of similar with the pictures and everything. So, okay, move on to the next problem. Sorry, I felt like I wasted a lot of time on those first two. Yeah, a lot of algebra, a lot of simplifying, substituting obviously for whatever variable you're given, and then solving for the ones you're not given. But yeah, and I was kind of in a hurry. I just realized that this assignment was due at 10 a.m. tomorrow instead of at the usual 11:59 p.m. And so I was kind of in a rush to hurry, as I was out of town all weekend and didn't get a chance to do much homework. So yeah, similar stuff here. You know, you get your initial velocity, you have your angles. I need to start drawing pictures on these so I understand what problem I'm talking about. Otherwise, it just looks like a bunch of scribbles, a bunch of math, which it is. But pictures would definitely help describe. I think there was only 14 problems on this assignment, but yeah. So that's pretty much it. Get your known variables, your unknown variables, obviously substituting certain things in for equations, differentiating between, or differentiating and integrating between, you have your position, your velocity, and your acceleration functions. What's also, I haven't actually seen this in a while, was these, you have your theta with the 2 dots above it. I remember seeing that a little bit in physics, but I guess it wasn't just super common notation at that time, but it's good to know we will be using that as well. But yeah, that's pretty much my assignment 1, or my chapter 11 homework there. So I'll go ahead and submit this to YouTube and send it over.